So let's get started with the test analysis for exam conducted on 24th. This is the first question. And the key part here is, this is typical circuit here. The galvanometer reads 0. Means this branch has 0 current, which implies if the current here is I, no current will pass through here, same current will flow through other resistance also. And if I broadly look at the circuit here, the circuit has two unknowns, I and X. And there are two equations in terms of Kirchhoff loop rule. And you can easily solve. Other way of thinking this question is, moment this becomes 0, this is equal to 2 volts. If this current is 0 here, the potential drop from here to here also has to be equal to 2 volts. There's no other potential drop taking place here. So if this is 2 volts, this is equal to 12 volts. So remaining potential drop has to happen across this resistance. 12. So 10 has to happen here, 2 has to happen here. So this is 10 volts. And since same current is flowing, potential drop has been proportional of the resistance. If the ratio is 1:5, the resistance ratio also has to be 1:5. X is equal to 100. So this is a fairly simple question. This is a two identical cell when connected in series and in parallel. This is a simple application of parallel and series combination of battery. So we know in case of series combination, first let's assume that EMF of each battery is E and internal resistance is R, and thus each one. So when we connect them in series, it will behave equivalent to a battery. What is the equivalent EMF in case of series combination? It will become equal to 2E, and equivalent resistance will become equal to 2R. Hence, the current when we connect to a 2 ohm resistance will become equal to EMF divided by the total resistance, 2EF divided by 2R plus 2 ohms. And same thing when it's connected in parallel, equivalent EMF becomes equal, it remains same if they're two identical batteries. Only internal resistance becomes half there since they are connected in parallel. In this case, the current becomes equal to EMF of the battery, which is E, divided by internal resistance plus the external resistance. These two are equal. When you equate, we can solve for R, and R comes equal to 2 ohms. So this also fairly straightforward application of equivalent battery. Okay, in this case, this is a potentiometer circuit. Only problem is the deflection decreases continuously until Y is reached. So here we don't get a balance point. No balance point. And what is the reason for no balance point? Clearly, if you look at this, I think from wording of the questions, pretty clear. The potential difference Vxy, even if we reach at this point also, the potential across these 2 points is not equal to EMF of the battery. It is less than that EMF. That's why I'm not getting the balance point. So what we need to do to increase potential difference across X and Y? Of course, you could have increased this EMF of the battery, but this is not one of the options. So what else can be done here to increase potential drop from here to here is reduce the potential drop across this. And how do we reduce the potential drop across this variable resistance? By decreasing the value of resistance. Okay, so decrease the resistance. That may help you obtain the balance point. It may. Why it is still, if V is less than E, even if you make it 0 also, we will not get a balance point. But that's the only option which may help in obtaining the balancing point here. This question we can solve as a, we can have this all are, each bulb can be treated as a resistance. So this also like R, and all are identical, all bulbs are R. So we can, what we can do, we can easily solve it a simple circuit. We can find current in each of this resistance, and we can calculate power consumption in each, and the one which has highest power consumption will burn the brightest. That's one way, very easily it can be solved. And another way to look at this question, but without any solution also, can we logically deduct which bulb will burn brightest? Let's see, can we do that? So it is connected like this. So if I have to draw a circuit, it's something like this. There are two bulbs A and B. So I denote those two bulbs by this resistance A and B. Both are equal resistance. And D is connected in parallel. And then finally it's connected to bulb C here. So this is a kind of circuit. All resistance are equal. Just by logic can I deduct which of the resistance will have maximum power consumption? Let this battery be E. Now, as you easily notice, there are two parts to the circuit. Whatever EMF we apply or whatever voltage we apply, it gets shared in two parts, V1 and V2. Where can we easily find out which one will be greater? See, this resistance will be less than R, and this is R. If this equivalent resistance is less than R, V1 will be less than V2. And power consumption in all resistance being equal, power consumption is proportional to square of the potential difference across the bulb. So if V2 is greater than V1, power consumption in C will be greater than D. And power consumption D, and whatever V1 we have, V1 gets further shared between A and B here. So this each one will have V1 by 2. So naturally, A and B will have even lesser power consumption than D. So clearly, which is the brightest? C is the brightest here. So without any calculation also, or we can find value of R, this R, and we can find a current, and we can calculate power consumption in each and find which one having maximum power consumption. This is error in reading of potential difference using a non-ideal voltmeter. What is the true value of voltage here? What is the volt across 100 ohm? True value if either we use ideal potentiometer or we either a voltmeter, or when this voltmeter is not connected. What are the potential difference across this point A and B? Very easily you can calculate. Let's see this value as E. It would have been equal to E into 100 divided by 110 total resistance. This was the reading earlier. Moment I connect, the resistance between A and B changes. What is the new value of resistance between A and B? It becomes equal to R1, R2 divided by R1 plus R2. So that becomes 900 into 100 divided by R1 plus 2000. That equals to 90 ohms. Moment this becomes 90 ohm. Now what is V dash across A and B? EMF remains same. Now from 100 it has become 90, and the total resistance also become 100. So what is percentage error here? Error divided by original value into 100. Error is, okay, let's write this error. And they're looking at absolute value only. So error value becomes E into 100 divided by, okay, simply I can write V minus V dash by V into 100. We can easily calculate, and that comes to 1%. A capacitor, this is something loss of energy in a circuit which has capacitor as well as resistance. So let's say we draw the circuit first. It gives an idea what is happening in the circuit here. There's a capacitor, there's a resistance, and capacitor is charged to potential V. If this is C, so one of them have positive terminal, let's say this is plus CV, and this is minus CV. So this is the plate which is having positive charge, this is having negative charge. How it is connected to battery? Through resistance. Positive charge plate of capacitor is connected to negative terminal. So this is positive charge plate is connected to negative terminal of battery. And this also potential difference is, and this also is V. Okay, so this how it is connected. Maybe there was a switch, and what will happen is connected to negative. How much is the heat dissipated? So first of all, let's see what will happen as soon as we make this connection. This is not the steady state. What will final state we know. Whenever in case of whenever a capacitor is connected to battery, the two plates of the capacitor has to acquire same potential as the battery with the same polarity. So what has to happen? The plate of capacitor connected to negative terminal has to have negative charge, and plate connected to positive terminal has to have positive charge. This is the final state. So it has to reach from here to here. This was the initial one, and from here this is the final one. So let's see this what does this involve? From initial to final state, it involves a charge transfer of how much? What is the charge flow? There's a current, and we are not interested in the current here. We're interested in what is happening overall over a long period of time. What is charge transfer? Very easily, charge transfer is equal to 2CV. So much charge moves from the negative terminal of the battery to positive terminal. It means what is the energy supplied by battery? And this energy which has been supplied to the whole system. from the chemical energy stored in the battery got converted. It has been converted, given in form of electrical energy. Energy supplied by battery will be equal to how much? dq into EMF of the battery, which is V. So that becomes equal to 2CV into V. That is 2CV square is the energy supplied. Where all this energy is gone? Has it led to any increase in potential energy? What is the increase in potential energy stayed in? Only place we can store potential energy is in the capacitor. But since the charge on the capacitor has not changed, increase in potential energy is zero. So where has that energy gone? Energy could have been shared between two things: increase in potential energy and the heat loss. Since change in potential energy is zero, entire thing gone in form of heat loss. What is heat dissipated? Heat dissipated is the entire energy supplied by the battery, which is equal to 2CV square. Okay. Next one, with velocity, the moment I look at this question is about helical motion. Okay. And helical motion, if you want to understand, many times is much easier when we draw magnetic field perpendicular to the plane of figure. So magnetic field along I cap. So I'm taking this B naught, this is the direction of magnetic field. So this becomes my I cap direction. So this is J cap and this is K cap. Let's see what the speed, how the projection is. Let's mark the projection different color so that we are clear about it. So projection is, it has I component, it has also a J component. So velocity has some component along the direction of magnetic field, V, and it has some J component as well. This also is V naught. So very clearly, the field acts like this. If we look at the two kind of motion, one I can think of motion in a circular plane perpendicular to magnetic field, and one is uniform motion along the magnetic field. So if I have to find, easiest to find would be what will the coordinate after time t. This time t, very clearly we notice this time is nothing but t by 2. Then from here, you see very clearly this is a dot field, and dot field it will move like this. Okay, so what will be the coordinate after time t by 2? Clearly, y coordinate is 0. So which one, this option is out, y coordinate is 0. Y coordinate, these two are 0. And second, the moment I identify these two, the second, okay, so y coordinate becomes 0. These two have 0 y coordinate. What will be z coordinate? Z coordinate will be equal to minus 2r. So this is minus 2r. And how about x coordinate? X coordinate will be equal to v into t, which is the term here. So this is the correct option. This is a fairly simple question. Yes, it becomes 0. I think I've done a number of times. If this becomes, this current is I here, this will be 3I. Okay, length is 1/3, but current is 3 times. So both will create equal and opposite force, and these two anyway directed towards center will not create any field. So 0 at the center of the loop. And this was one of the very easy question. And this also a very easy question. If you make a loop, radius becomes 1/3, number of terms become 3, so field becomes 9 times. Okay, this is east-west kind of question. Some people have little difficulty, and as we mentioned earlier, whenever this kind of directions are involved, we can always make use of coordinate system. So if you are not sure, we can use coordinate system, or you can also use right-hand thumb rule, whichever you feel more comfortable with. If I have to use coordinate system, something like this I can draw. I can represent those direction, horizontal plane. So this is east direction, I can represent as I cap. And this is north direction, J cap, and right hand thumb rule, upwards direction becomes K cap. And what is happening here? Let's see, let's mark that one. Electron is moving towards east. So there's a charge minus E is moving towards east. Okay, so what you need to find, which direction the force is acting. So simply we need to find the magnetic force. And what is it? It's just, now it is very simple. We can use vector cross product. So what is V equal to? Charge into Vi cross and Bj cap. So as far as direction is concerned, what is the direction? Direction is I get a negative term here, I cross J. That's the direction. And this is Ij is K cap, so minus K cap. What does minus K cap indicate? Particularly downwards. So this is the option. This is also fairly simple question. This is based on field being proportional to 1 by r cube. R being the inclined distance. Here magnetic dipole moment is not changing, hence the field is directly proportional to r cube, and very easily you can find the answer is equal to something like this. Is it not? It is like this. So this is r, and this is initial value. So initial, and this r to become field to become 1/8, this has to be equal to 2r. Then field becomes 1/8. Okay, this case of ion, both positive and negative ions are present, and initially they are at rest in presence of simultaneous electric field and magnetic field. So again, let's draw a figure perpendicular to magnetic field, and that's also as we are clear. So the magnetic field is along z-axis, so I draw x-axis, y-axis, and magnetic field is this. This is the magnetic field along k cap. So this is my okay, x-axis, y-axis. Now let's take one by one. Suppose there's a positive charge here. A positive charge is released from origin because, and this, sorry, there's forward. There's electric field also in x direction. There's E also. So positive charge initially it will be acted upon only electrostatic force. Because electrostatic force, it will acquire some velocity along x direction. As long as it acquires a velocity, magnetic force also will start acting, and positive charge dot right. So force will act towards right. So this how the it will bend which direction? This is the direction of force acting on the positive charge. It will bend along negative y direction. Now let's look at the negative charge. What will happen if there's negative charge? Negative charge, okay, where is that gone? Okay, so negative charge, force acting on the negative charge, it will force will be opposite the direction of electric field. Hence, the negative charge will acquire a velocity also like this. And in this case, positive charge will act towards right, negative charge of force will act towards left. So force will be, this is the direction of force, which is same as in the positive charge. Even this also will move along negative y direction. So all charges, all ion deflect towards negative y direction. This is a very direct question. So as the angle keeps up decreasing order, arrange in the decreasing angle. So decreasing order of angle, this, followed by this, followed by this, and this. So 1, 4, 2, 3. 1, 4, 2, 3, this option. This is also electron, negative charge moving in this. Electron exit from the region with speed v. So very clearly we know kinetic energy does not change. So U has to be equal to V. So the U is equal to these two options are gone. So only question is now, will it bend like this, it will exit, or it will exit like this? So we can find the direction of force. If I'm not comfortable, I can always use IJK. And in this case, the force will act towards negative y-axis. Hence, it will bend downwards. It will exit at a point where having negative y. That's the correct option. Okay. This case, see, we had done number of cases about EMF. What is EMF equal to? EMF equal to EMF induced is equal to d phi by dt. And d phi by dt, unless this multiple loop, if it is single loop, it is equal to b into a, especially when cos theta is equal to 1, as is the case here. But unlike many other cases, here both may change. So what is EMF is equal to? It is equal to b into dA by dt, rate at which area is changing, plus A into dB by dt. And it has to be equal to 0. Quite clearly, this is increasing. Area is increasing as it moves in this direction. So this term is positive to for it become, this term has to be negative. It means the dB by dt has to decrease. So first of all, increase not change option is gone, and increase option is gone. Now, only thing I have to think is a dB by dt is a linearly varied time. If it is linearly varying means what? If a linear varying means is dB by dt is equal to negative constant. Then only it is a negative variation, negative linear variation. It will be a straight line equation. dy by dx is equal to constant. And decrease linearly means, so I have to check, is it a constant or a not? That's the only thing we have to check. So let's see that one. In this case, let me take a simpler case. This is x coordinate. Velocity is v. I'm assuming it started from origin. Doesn't matter because I'm just check this option. So what is x coordinate? X coordinate velocity is v equal to x coordinate is v naught t. Let's put this value. If x is v0 to, what is flux B equal to? D by dt. B into v0 t into L. Let's this be L. So what is this term comes to? It comes equal to B into v0 L, first one. And the second term area is equal to v0 t L into dB by dt. Is d by dt is constant? No, there's a t term here. There's a t term here, it is not a constant. So basically it decreases non-linearly with time. Okay, here also it has velocity, something like this. Again, we can use principle of superposition kind of thing. We can analyze in two parts. Force we have to calculate. Two parts is what? One, it is moving. We split the velocity into two components. Let's see whether it, because see, first case, let's say, if what happens when it is moving like this. And the second case we look at, and what will the force, net force? So we'll take the vector sum of the two cases. Other case it is moving like this. Okay. In this case, what will happen here? The field is changing only along x-axis. So if this direction only field is increasing, the field is increasing in this direction, x direction, though it is in the. So if I look at here, these two will not experience any force. First of all, when given a velocity like this, for it to experience a force, there has to be EMF. As it moves along this direction from, suppose if it is moving along, we are given a velocity along positive x-axis. When it has moved here from here to here, has the flux changed? Actually, the flux is not changed. Is x coordinate, every part of the loop, is x coordinate position is not changed. If x coordinate position is not changed, it has moved from similar flux to another flux region. So whatever the flux was here in this part, here also the similar area we take, flux remains same. So no change in flux, no EMF, no current. So this will not, and even if there's a current also, see B, if we take symmetrical pair of elements, since both will have same value of field, current in the opposite direction, force will cancel out, zero force. This does not create force. Now, when you look at in this case here, see, in this case, force due to magnetic field. First of all, it is moving from here to something like this. This is velocity given. It is moving from a lower magnetic field to higher magnetic field. Field is increasing in the direction of x. So flux is increasing. So what has to be induced EMF or what has to be induced current? It has to oppose the increase. That's why the current has to be in this direction. When current is flowing in this direction, now the question comes, how about force? Again, as a similar logic, what you use pair here. So if I take corresponding pair here, both are having same value of magnetic field, same value of current. Forces will cancel out. This will not create any force. But if I take this element and this element, here the B is less, here B is more. So this force on the right hand side, will be greater than the force on the left hand side. So what is the net direction of force? Net direction of force is same as direction of force on right hand arm of the loop. And what is the direction of force? This is the direction of current. And what is the direction of B? This is the direction of B. So can we find the direction of force L cross B? So L cross B means B is yeah, you can do vector also. You can do IJK. So those who are not comfortable, again, you could have done. What will the direction of FB? I'm just finding the direction. The direction L vector is in which direction? In this case, same as I direction, J cap. And cross of field is along minus K. So JK, so it is minus I cap. So this force, though I have drawn here, what I find here, actually the force is acting in the leftward direction. So direction of force is same as in the, so if I draw this force, draw the loop again, what I understand here is the force will be like this. On this arm, right arm, force will act in this direction. And force on the other arm will act on the rightward direction, but that's a smaller. This is the direction of force acting on the loop, which is along negative x direction. Next one. This is pretty silly, simple one. These two are plane or two fixed rail. R and S are fixed. These two are fixed. So if P is moved, this one is moved in this direction, what will happen to rod Q? The effect of moving the P here is actually, when we are thinking was what is the cause which will create current, which will create change in flux and EMF and force, is because P is moving farther away from Q. How should Q respond to oppose the cause which is moving away? It will tend to move towards P. So very simple application of Lenz's law. It will move towards P. It will be attracted towards P. Okay, but this is a question that exists a uniform magnetic field and electric field in an upward direction. What is the maximum height is? It's a question, almost a three-dimensional visualization this question might need. So let's draw the axis and let's take vertical axis in the upward direction. A typical coordinate system, vertical in the upward direction. So this is X coordinate, Y is, and this is upward Z. And let's see what is given here. There exists a uniform magnetic field. Magnetic field is along this direction. And this electric field also in the same direction. Both are in the upward direction. And let's see what the velocity of the charge particle is, which direction it is projected in. This minus Q charge, it is given velocity, it has component of velocity in this direction, which is perpendicular magnetic field, which will give you circular motion. And it also has a component along Z direction. What is the velocity it has in this direction? It has velocity B here. So question we have to find the maximum height is the particle. What is the maximum height it will reach? First of all, why it will reach only maximum height and come back? So this question involves motion only in vertical direction. Other directions we are not concerned. What is happening XY plane is irrelevant. So let's look at focus only on Z direction. So Z direction, what are things which are given? What kind of motion in Z direction it has? It is initial velocity UZ is equal to B. That's the direction. And what forces are acting in the Z direction? Is there any force acting in Z direction? Force acting is because electric field. So Fz is equal to Q. What is that equal to? Minus Q into E. So there's a force acting in the downward direction. Hence, there's an acceleration in Z direction, which is also equal to QE by M. So whenever velocity and acceleration in the opposite direction, and this is a uniform acceleration. So I can use the formulas for uniform acceleration. And whenever something like this is very similar to case of a projectile projected vertically up. Okay, and so whenever acceleration is opposite to velocity, it will gradually keep slowing down and comes to a state of momentary rest, and this is the farthest point. So what is the Z maximum value of Z? What is the maximum height will reach? See, we calculate in terms of gravity, we can use directly that formula, V square by 2G kind of thing. What is V? Velocity in the direction, G is the acceleration in the direction. That is the opposite direction velocity. So that would be equal to B square divided by twice the acceleration, twice QE by M. So that becomes equal to mb square by 2QE. Next one. Resistors. So here, which of the following cannot be the balancing length? Whenever this question, this is something answer comes into the range, we need to find what is the range of balancing length. And anything which is falling within the range is possible. Anything which is outside the range, it is not possible. So if I connect two resistors X and Y in the typical meter bridge setting, we'll have minimum value when X is minimum and Y is maximum. And that's the minimum balancing length. And when will the balancing length be maximum? Reverse of this. When resistance on the left hand side is maximum and on the right hand side is minimum. So in this case, what is the range of resistance? Actually, value of resistance doesn't matter. Only thing in matters is silver. So basically means if the resistance is R, its maximum value could be 1.1 R and its minimum value can be 0.9 R. That's the range resistance will have given this color code. Now, in this case, so what will the setting here? For minimum reading, what will the condition? For minimum reading, X has to be equal to 0.9 R. and y has to be equal to 1.1 r. So what will my, if balancing length, if my balancing length is L, L divided by 100 minus L will be equal to x by y, which is equal to 0.9 by 1.1. So what is the value of L I get? L I get equal to 45 centimeter. Similarly, if I calculate maximum, L comes equal to 55 centimeter. So which means any reading between 45 and 55 is possible. So this is possible, this is possible, this is possible, this is not possible. So D is the correct answer. Okay, this is a question. This is a little tricky question. Okay, what is given? Magnetic field is given by X. This is not a constant magnet. This is not a uniform magnetic field. And what we had to, I think we had done something similar in case of flux. So if when X is positive, it will be along K cap. X is negative, it will be along minus K cap. So let's draw a figure which is perpendicular to the plane of magnetic field. That's something it makes a little easier. So something like this. A circular coil is placed, current is in the clockwise sense. So this is x-axis and this is y-axis. Let me take a circular coil. Oh, doesn't look great, but it's okay. This is circular coil. And it is, if I have, this is my k-cap direction or z direction. If I look from here, what is given? The direction is clockwise. So what I need to do is, magnetic field is not constant. So what you can do, since right hand side, if I look at the direction of magnetic field here, on the right half, when x is positive, the field is like this. This is the direction of field. Whereas on the left half, field is like this. So what I'll do to analyze what is happening to the coil, which direction the forces will act, let me consider the right part and let me take the pair of elements. What is the pair of elements? Let me draw a line so that if I draw the line, the elements between these two lines are having same field. Okay, so this element would be plus BC. So we have taken, first of all, I divided this whole coil into two parts, left half and right half. And right half also had taken a pair of symmetrical elements. And why we're taking pair of symmetrical elements? We have to take advantage of symmetry, something may cancel out. So let me take, and this is a small element here. And this is the direction in which the current will flow. And this is the direction in which the current will flow. And both will have same value of B and L, everything is same, theta also same. The magnitude of force acting on the two elements will be equal. And this is dot field, and which direction the force will act, you can easily find out the direction in which the force will act will be like this. And towards is right, and here also it will act towards right. So these are the forces acting. So as soon as the two forces are equal, what I need, same thing will happen with different pair of elements here. So what is the resultant force on the two elements, a pair of element? Resultant force is negative x direction. Similarly, let me take another pair on the left hand side. Okay, let me draw two pairs on the left hand side. Here also I take two pair at this also again a similar equidistant from the y-axis, so that x coordinates are equal and both are negative. Now force, this is negative, the force will act in the left direction. This is how the force will act here, and this is how the force will act here. You can find out from the right hand thumb rule. And forces being equal, again vertical components will cancel out. This also is creating a net force towards left direction. So if I take all such pairs, left hand side and right hand side, all will be acting in this direction. So overall, net force will act towards negative y-axis. Okay. Will there be any torque? Torque is very easy to understand, because since magnetic field is perpendicular to xy plane, forces will act only in xy plane, and coil also lies in xy plane. The forces acting in the same plane will not create a torque, and they will keep cancelling each other. So no torque will act. So this answer. Next question, bulb consume radiated power. So this is something again we can solve, draw a circuit and take this rated power and all, we can calculate, but we can find a simpler way also. What has to happen for it to consume? See what is given here, it will have a power consumption of 0.5 watts when connected to 3 volts. So what is this resistance equal to? We know the power is equal to V square by R. So let's first find out what is resistance value. Resistance is equal to V square by R, 3 square divided by 3 square by P, which is equal to 18 ohms. So this one is 18 ohm resistor. When it's connected to 3 volts, it will consume a rated power. So what has to happen? The R should be such that from here to here, the potential difference should become equal to 3V. Then we consume the rated power. That's the voltage. If this is 3V, the remaining part also has to be 3V. So if I use that understanding, it becomes a lot easier to solve. Let me do how to say. So this battery, I'll just draw it here. It doesn't make a difference. I'm changing the position of the battery so that picture looks clearer. So this part is something like this. There's a lamp here on the upper bar. These resistance are connected here, and they are 4 ohm and 0.4. I combine into one. This becomes equal to 4.5. So what is the condition for it to consume rated power? This battery is 6 volts. From here to here, it has to be 3 volts. Then same voltage. And this also, if this is 3 volts, this also has to be 3 volts. In other way of saying, this equivalent resistance has to be equal to 4.5. If the two resistances are equal, then only potentials are equal. Okay, and so this is R and this is 18. The equivalent of R and 18 has to be equal to 4.5. That's the condition. 18 into R divided by 18 plus R is equal to 4.5. And you can easily calculate the value of R, which comes equal to 6 ohms. Okay, this case, what is this case about? A particular ring of resistance R. So ring has resistance to R, and sliding on frictionless surface, there's a rest of it. So if I look at the resistance, where is the resistance here? Let me mark the part which has resistance in this case. The resistance is only in the ring. Rest of the rails and all do not have resistance. This part only has the resistance. And it is sliding velocity V. Okay, so there's a uniform magnetic field perpendicular to plane of the ring. So then which direction? Direction is not very relevant here. This is the field here. The speed of ring is V. What is the current? I need to find this current here. See, whenever it is falling like this, I can, it's like a moving conductor, and I can replace with, first I can find EMF, the top half of the ring, bottom half of the ring. I take each part separately. So top half will have some EMF, and what is the EMF the top half will have? And both will have same orientation. So this, if this is like this also will be like this. Okay. So if this, what will this EMF? So it will act, and there will be some resistance also. What is resistance? The top half will have R by 2, bottom also R by 2. Essentially, what will happen? Each half will act as a battery of EMF BLV, internal resistance equal to R by 2, and then we need to find current. So let me draw what the circuit is, equivalent circuit would look like. Equivalent circuit would look like something like this. R by 2. And what is the resistive EMF here? BLV. B into length becomes 2R. So B into 2R into V. And another also is equal to R by 2. And same thing. EMF is equal to, sorry, what I'm writing. This is EMF. And this EMF here. EMF is equal to B into 2R into V. And it is connected, and what we need to go is connected to point P and Q. I need to find this current here. This is whenever you can easily solve, we can replace an equivalent battery. This is two batteries connected in, as two identical batteries connected in parallel. So its equivalent resistance becomes half, which becomes R by 4. EMF remains same, which becomes to 2 BRV. And then we have to find current, which is easy. Current I is equal to 2 BRV divided by R by 4, which is equal to 8 BRV by capital R. So here, what is the coefficient? K times is equal to 8. It's a pretty simple question. Per time period. This is just based on intermagnetic field. What is time period equal to? Time period is equal to 2 pi m by qb. In this case, magnetic field is same, uniform magnetic field. So it is based on ratio of time period is proportional to mass by charge. Okay, and what is the time period takes time period for proton is given as it is 25 seconds for 5 revolution for each one, 5 microsecond. So what will be T alpha by T proton? Mass by charge of alpha by mass by charge of proton. It's a fairly simple question. You can easily get your answer. Okay, this question also as a question of potentiometer. This resistance is given as 10 ohms. Is connected in series resistance of this one is 40 ohms, and EMF of the battery is 2 volts. Okay, so balancing length, we can easily find the potential gradient. What would the potential gradient be? You can first find out the current. Current is equal to 2 divided by 50. And the length is 1, so that becomes my potential gradient. Potential gradient is also in terms of 250 volts divided by 1 meter, that many volts per meter. So that becomes equal to 0.4 volts per meter. Okay, and in this case, the balancing length is found as 40 centimeter. So what is E equal to? E is equal to phi L, 0.4. And since this is volts per meter, this length also I have to write in meters, equal to 0.4. So this is equal to 0.16 volts. Total current supplied to the battery. If this is I, that's what we need to find. Again, this is a question of finding equivalent resistance. So let's say point this all these points are potential A, and let me this potential B. Sorry. Okay. So what are the potential points here? Let's see. Call this this is A, and this is B, and this all these are C. So battery is connected between A and C. So something like A and C, battery is connected. This is C end and positive end is A end. So how is this 6 ohm connected? There's some point in B in between. So 2 ohm is connected between A and B. And 6 ohm also is connected between A and B. And 1.4 ohm is connected between B and C. And what we need to find, we have to find this value of current, which is fairly simple. We find the equivalent resistance, which is equal to, yeah, pretty simple question. You can easily find an answer. Okay, so that's all. So we'll end it here.